Good morning all. So in today's class we will look at what are called indeterminate forms and a rule to evaluate a limit when you have an indeterminate form. So that rule is called the L'Hospital's rule. Now usually suppose you are evaluating a limit. Okay. So let us have a limit of the form limit x tends to a f of x by g of x. Now usually limit evaluate we'll substitute the value of x to be a. So if you get a finite value, that will be the limit, or your limit can be plus or minus infinity, or limit need not exist in few cases. By indeterminate form you mean, so when you substitute the value of x into this function. So, ingane avanathilla function. So, suppose you have a limit, say you have a function in this form. So, you have a limit in this form. This can be anything. F of x can be either a product, can be quotient, it can be some exponent or anything. Okay. So, when you substitute the value of x, sometimes your function can be in the form either 0 by 0, or it can be in the form infinity by infinity. So, or it can be in the form infinity minus infinity form. Then you can have in the form 0 raised to 0, and you can obtain in the form infinity raised to 0, then you can obtain in the form 1 raised to infinity, so on. So, all these forms, so these values are not defined, or these are called indeterminate forms. So, I do not know what is exactly 0 by 0 or what is exactly infinity by infinity. Okay. So, such forms, if your limit appears in such forms, so they are called the limits in indeterminate forms, and we are going to evaluate such limits. Namukku limits ingane varuna case we can use L'Hospital's rule. Okay. And remember, whenever you solve problems, L'Hospital rule nammal indeterminate forms ന് മാത്രമാണ് യൂസ് ചെയ്യുക. അപ്പം ഞാൻ ഇവിടെ ലിമിറ്റിന്റെ വാല്യൂ എടുക്കുമ്പോൾ എനിക്ക് ഒരു finite value kittuvaanengil, that is the value of the limit. So in that case, do not apply L'Hospital's rule in that case. So L'Hospital rules work only when you have functions appearing in the indeterminate form, as we take a limit x tends to a. So these are the different types of indeterminate forms. So in each case we will see how to evaluate the limits. So first we'll see the indeterminate forms of type 0 by 0 and how to evaluate the limits. Okay. So let us define an indeterminate form of 0 by 0 type. So suppose you have a limit of the form limit x tends to a f of x by g of x. So let me call it as equation 1, in which, so you have f of x approaching to 0 and g of x approaching to 0 as x tends to a. So you have a limit of this form where as x tends to a, numerator goes to 0, and as x tends to a, denominator also goes to 0. അപ്പം നമ്മൾ a value substitute ചെയ്യുമ്പോൾ you will get in the form 0 by 0. Okay. So for example, if you have say something like this, so limit x tends to 1 x minus 1 by x square minus 1. So as x approaches to 1, your numerator is 0 and your denominator is also 0. So this is an indeterminate form here. Okay. So this is called an indeterminate form of type 0 by 0. And now this is equation 1, and so suppose 1 is an indeterminate form of type 0 by 0, and L'Hospital rule is applied when your function must be differentiable in that case. Appo nammade f um g um differentiable aanu, that means f dash and g dash exist and they are continuous at x equal to a, and here you have g dash of a equal to 0. So if you have the functions f and g such that it satisfies these conditions, okay, appo f um g um differentiable aanu and the functions f dash and g dash are continuous at x equal to a and g dash of a is not equal to 0. So this is how we have the functions f and g. Ini nammada function about a point a differentiable aanengil, so every function can be approximated by a polynomial of degree 1. So that is called a local linear approximation. So f and g can be approximated by the local linear approximation. Appo local linear approximation nu parnal, so f of x can be approximately so this f of x will be approximately equal to f of a plus f dash of a into x minus a. This you will study later what is local linear approximation. Okay, so nammal idana ivide use cheyunu. So nammada function differentiable aanengil about a point a, so function will be approximately equal to f of a plus f dash of a into x minus a. Same g differentiable aanu, so g can be also put in the form g of a plus g dash of a into x minus a. So this limit will be approximately equal to this limit. Ini namukku limit eduthu kazhiyumbo, so here as x approaches to a, f of a will be 0, g of a will be 0, so ee rendu terms um povum, and ini f dash and g dash, since they are continuous at a by the condition for continuity. If you have a function f of x which is continuous at x equal to a, then limit x tends to a, f of x ennu parayunna f of a aayirikkum. Appo f dash g dash continuous aayadonde when you take the limit of f dash and g dash, so that will be equal to f dash of a and g dash of a respectively. So this limits will be f dash and g dash, and now the first term becomes 0. Appo nammakku first term 0 avum, f of a and g of a 0 aanu, and the second term x minus a will cancel off, so remaining you will get limit x tends to a, f dash of a, g dash of a. Now this can be rewritten under the form limit x tends to a, f dash of x by g dash of x. So what we have got at the end, so we started with limit x tends to a, f of x by g of x. So limit x tends to a, f of x by g of x will be equal to limit x tends to a, f dash by g dash. So that is the L'Hospital's rule. So here in the L'Hospital rule, so the given indeterminate form is converted into a limit which is involving derivatives, and that limit will be often easier to evaluate. So let us state it as a theorem. So the L'Hospital rule for 0 by 0 form states that if f and g are differentiable functions on an open interval containing a, except possibly at x equal to a, but x equal to a function may or may not be defined, and limit x tends to a, f of x is 0, and limit x tends to a, g of x is equal to 0, and if limit x tends to a, f dash of x by g dash of x exists, or if it is infinity or minus infinity, then L'Hospital rule states that limit x tends to a, f of x by g of x will be equal to limit x tends to a, f dash of x by g dash of x. And here instead of limit x tends to a, the rule will work for limit x tends to, you can have left limit or right limit, and infinite limits. It can be limit x tends to a plus, limit x tends to a minus, and limit x tends to infinity, or limit x tends to minus infinity. So provided it is in the 0 by 0 form, and functions f and g differentiable anengil, this limit will be equal to limit of f dash by g dash. So take the derivative of the numerator and the derivative of the denominator. Okay. So the rule will work when you have x tends to a minus, x tends to a plus, x tends to minus infinity, and x tends to plus infinity. And remember one thing when you solve problems, so El Hospital rule is applicable only when we have limits in indeterminate form. Where ഒരു ഫോംസിനും നമുക്ക് ലിമിറ്റ് ഫൈനൈറ്റ് വാല്യൂ ആണെങ്കിൽ അവിടെ ഒരിക്കലും എൽ ഹോസ്പിറ്റൽ റൂൾ അപ്ലൈ ചെയ്യേണ്ടി കാര്യമില്ല. സോ ഇറ്റ് വിൽ വർക്ക് ഓൺലി വെൻ ലിമിറ്റ് ഇസ് ഇൻ ദി ഇൻഡിറ്റർമിനേറ്റ് ഫോം. So let us see a few problems. So evaluate the following limits. So first one is limit x tends to 0 sin 2x by x. So you can see that limit x tends to 0, sin 2x is 0, and when you take limit x tends to 0, x, so that is equal to 0. So limit of x tends to 0, f of x is 0, and limit x tends to 0, g of x is 0. So this is in 0 by 0 form. അപ്പോൾ നിങ്ങൾ പ്രോബ്ലംസ് ചെയ്യുമ്പോൾ ആദ്യം ഏത് ഫോമിലാണെന്ന് ഐഡൻറ്റിഫൈ ചെയ്യുക, അത് എഴുതുക. സോ therefore by El Hospital's rule, so limit x tends to 0 sin 2x by x, that will be equal to limit x tends to 0, so take the derivative of the numerator, so that will be 2 cos 2x by 1. So now take the limit, so that will be 2 cos 0, so that will be equal to 1. So therefore the limit is equal to 1. And the second problem is limit x tends to pi by 2, 1 minus sin x by cos x. So when you take limit x tends to pi by 2, 1 minus sin x, so that is 0. So limit x tends to pi by 2, cos x is again 0. So this is in 0 by 0 form. So by El Hospital rule, so that will be equal to limit x tends to pi by 2. Take the derivative of the numerator, so that will be minus cos x by minus sin x by El Hospital's rule. So which will be equal to, so as you take the limit, cos pi by 2 0 varum, sin pi by 2 1 varum. So it will be equal to 0 by 1, so it's equal to 0. And if your limit x tends to 0, e raised to x minus 1 by x cube. So you can see that numerator e raised to 0 is 1, upon 1 minus 1, 0 varum, 0 by 0 formula. So by El Hospital rule, so that will be limit x tends to 0, we have e raised to x, derivative 1 is 0, by 3 x square. So this is by El Hospital rule. And now when you take the limit now, limit is in the form 1 by 0 varum, so that is infinity. So the limit is infinite in this case.